Okay, now welcome to the video number 3, that is. Now I am defining what is electric displacement. It is a vector quantity. Sometimes it is called electric displacement, electric flux, electric induction. That also they will call it as. The word induction, why they are using it, just now I told you one capacitor is there here. This is the positively charged and this is plate is what? Negatively charged and all that. Now I place the word dielectric material and all that. I said that by phenomenon of induction, negative, 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 negative. Here it is what? Positive, positive, positive. This is what? Induction. How much it is electrically charged? That is what? It is how much, what is the response of the material? Listen carefully. Electric displacement, nothing but what is the response of the material under the influence of the external electric field is nothing but electric displacement. I know that, but you will not understand so easily that is. Displacement, actual meaning is, mathematically you will not understand the physics. Displacement, nothing but, here electric displacement is nothing but what is the response of the material. What is the response of the material by inducing the charges? You see, here negative charge is produced and here it is what? The positive charge is produced on the dielectric material. Here negative, here negative, here negative. Why negative? Because this is positive. It is what? So that it is bounded by these two. Here it is positive, 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 positive. Because these positive charges are bounded by what? Negative. What is the response of the material in distributing the charges when it is subjected to the external electrical field is nothing but electric displacement. It is used to find the response. It is used to find the response of the material. Response of the material means it is what? Dielectric. To find the response of the material on the application of external electric field. This material on the, it is used to find the response of the material on the material in presence of external electric field. In presence of, it is used to find the response of the material in presence of external electric field. External electric field. This is actual meaning of displacement. Very important points towards, but unfortunately no one book, that is books, will not explain this point. Just they will write mathematically, they will write. Here, how much that is what? Redistribution of the charge is negative and positive will takes place. Now, this will be differs from one material to what? Another material and all that. This is nothing but displacement, or sometimes it is called as electric flux also. Now I will go to derive the mathematical equation. How to write mathematical steps. Electric intensity. I will repeat all these things. Electric displacement, electric flux, electric induction, all are same. Electric intensity due to a point charge, Q at a distance R is given by E equal to 1 divided by 4 pi epsilon naught into Q divided by R square. This is standard definition. Now I will rewrite this equation. E equal to Q divided by 4 pi R square into what? 1 by what? Epsilon naught I will write. Here you see, what is this quantity here? It is charge divided by area, is it not? This Q is the what? Charge. This 4 pi R square is the what? Area. Charge per unit area is nothing but what? Flux. Charge per unit area is nothing but what? Flux. Just now I told you electric displacement, or it is called as what? Electric flux. I will call it as what? Electric flux. Both are what? Same here. This is nothing but what? Flux. Electric flux. Charge per unit area is nothing but electric flux. Electric flux, another name is what? Electric displacement. So that I will write E equal to D divided by what? Epsilon naught. Epsilon naught is a subscript. Or else it is D of media. D equal to epsilon naught into what? E students. I think you understood that. Here you see, it is a general equation for the electric charge. 1 by 4 pi epsilon naught into Q by what? R square and all that. I rearrange the term here. It is Q divided by 4 pi into what? 1 by epsilon naught. What is this quantity? It is nothing but charge per unit area is nothing but what? Electric flux. That is another meaning of electric flux is nothing but what? Electric displacement. That's why E equal to D divided by what? Epsilon naught. That is, or D equal to epsilon naught into E in vector form. This is also vector quantity. This is also what? Vector quantity and all that. Suppose if it is any other than air medium, it is any alcohol is there, copper is there, it is benzene is there. In that case, it is not epsilon, but you have to write what? Epsilon you have to write. In that case, here D bar equal to epsilon into what? This is what? Medium. D of medium equal to epsilon naught. It's not epsilon naught, it is epsilon into what? E and all that. This is, remember, this term. What is D of medium? Equal to what? Epsilon E. This term I am using in the next derivation I am using. Next, I am writing this. D equal to epsilon into what? E that is. This is what? Medium equal to. Okay. Next, derive the equation that is. Let me ask you this important derivation that is. Relation between susceptibility. It is called as it is not magnetic susceptibility. It is called as an electric susceptibility and relative permittivity. Epsilon. Derive the equation for it. Okay. Draw one diagram. You draw it. Already shown that this is the plate. It's the parallel plate. This plate is what? Positively charged. This plate is negatively charged. What is filled here? Air is filled. Okay. Next, I am placing one dielectric material and place. Same plate. This is positive. This is positive. This is negative. Okay. I will place a dielectric material. Okay. Dielectric nothing but it is an insulator. In insulator there is no free electrons. But when they are subjected to the external electrical field, there is a redistribution of the positive and negative charges. Initially it is electrically neutral, but now it is a displacement. Because of this displacement, what happens? Here it is negative. Here it is positive, and what? Positive is what? Created. Now I will write the equation. The electric displacement in isotropic. Here it is a dielectric medium. In an isotropic medium, the term itself indicates that isotropic means uniform material. That is only one kind of material. Here, uniformly. d of medium equal to epsilon naught into E plus of P is nothing but polarization. This is first event net. It is arises because of what? Induced charges and all that. Next. But just now I told you that this is equation number 1. And we know that d of medium equal to epsilon into what? This is equation number 2. Substitute here. Epsilon into E equal to epsilon naught into E plus of what? P. It is. Now P equal to epsilon into E minus epsilon naught into what? E. Now recall your definition of relative permittivity just now in the previous video. Here epsilon r equal to what? Epsilon divided by what? Epsilon naught. Therefore epsilon equal to epsilon r into what? Epsilon naught. I think you understood this. Substitute this P equal to epsilon r into what? Epsilon naught minus, okay, this one, into E minus epsilon naught into what? E. Which is the common factor here? Common factor P equal to, I think this quantity, epsilon naught into E. Here also epsilon naught into E is what? Common factor. Here epsilon naught into E into bracket epsilon r minus of what? 1 here. This is the quantity. Or else, can I write like this? Epsilon r minus of 1 equal to P divided by epsilon naught into E, this one, epsilon. But this quantity is there, no? This is, it is this quantity, P divided by this quantity, it is nothing but mathematically epsilon r minus of 1 equal to what? This is called as susceptibility. Or else epsilon r equal to plus of what? 1. This is called as electric susceptibility. That means it measures how easily the substance can be what? Polarized. The susceptibility, the term indicates that how easily, whenever it is subjected to the external electric field, how easily the substance can be what? Polarized in the presence of the external electric field. This is the meaning of what? Polarizability. And the value of this susceptibility is that now it will varies from one material to what? Another material. If this high value it is more, then that material is said to be dielectrically, it is very, very good. That material you can use it for the what? For the as a dielectric material medium in preparing the batteries and all that. Okay, I think you understood. This is important derivation. Derive the relation between the permittivity, relative permittivity, and what? Susceptibility. What is susceptibility? The word susceptibility indicates that how easily the material can be what? Polarized in the presence of the what? External electric field. And this value is varies from one material to what? Another material. This value is always, it is positive quantity. How do you say that it is positive quantity? Epsilon r is always positive. Then this should be what? Always it is what? Positive. And also it is more than what? 1 only, that is. Okay. This is regarding the what? It is regarding the relation between the susceptibility and relative permittivity. Now I will solve one problem and solve it. On this. Which equation are using here? Epsilon r minus of 1 equal to, what is this? Susceptibility. Where susceptibility equal to, what is this? P divided by epsilon naught into what? E. This is the formula. Okay. I will do one problem on it. Calculate the calculate the polarization and susceptibility. Calculate the polarization and susceptibility of the material it is subjected to external voltage, electric voltage. It is 5 volt. External voltage is 5 volt across the dielectric constant of thickness 2 millimeter. This is the quantity, that's 2 millimeter. Okay. Now, what are the given quantities are there here? Voltage has given. Voltage is equal to how much it is? 5 volt. And thickness of the material equal to how much it is? 2 millimeter. Thickness is given and this. What are to be calculated here? Now, P equal to, you know that, epsilon naught into epsilon r minus of 1 into what? E. This is the equation, that is epsilon. Okay. Now, and another quantity is there, dielectric constant. It is K equal to, what is this? 6 I have, no unit for it. Substitute all this. P equal to epsilon naught value, you know that, epsilon naught, it is 8.852 into 10 to the power of what? Minus 12. And epsilon r is nothing but what? K. That is 6 minus 1 into, what is the, here E has, but I don't know the E, but I know the voltage. We know that in the PUC know that electric intensity equal to V divided by what? D. What is D? Thickness. You know that P equal to 8.852 into 10 to the power of minus 12. 6 minus 1 is 5. What is the voltage here? 5 volt. And what is the thickness here? 2 millimeter. 2 into 10 to the power of what? Minus 3. Substitute all these values and then calculate the value of P. You can calculate. And this unit is coulomb per meter square. The unit is very, very important. Next is what? Susceptibility. Susceptibility equal to, what is this? Epsilon r minus of 1. What is the epsilon r? Is nothing but what? 6. 6 minus 1 equal to what? 5. That's all. Very easiest. Okay. Now I will stop my discussion today for this. Next, tomorrow I will discuss the further part of it. Okay. Thank you, one and all. And please go through this video. I made very small videos I made here. And look into this. Watch this carefully. If you have any difficulties, suppose if you feel this, give your feedback is important. But nowadays, nobody is interacting with me. That is what. Even earlier also the chapter, I think probably I made the 8 videos are made. But while looking to that, many of them, the viewers are there and all that. Please, anyway, look into this. And what kind of improvement is required from my side. If you suggest, then I will incorporate those things in the next video. I will incorporate it. Thank you, one and all.